Hello dear students, the portions pending in the previous video lecture will be covered in this video lecture. Due to lack of time, I shifted to a new video lecture. So in this video lecture, slowly we can cover these topics. So first let us look into design strength of columns according to class 7.1, then table 7 and figure 8 of page number 34 and 35 of IS 800-2007. So here the design strength 7.1 completely dedicated for the design of compression members. So here let us see this 7.1.11 sorry 7.1.1. So here what they have given is common hot rolled and built up steel members used to carrying axial compression usually fail by flexural buckling. The buckling strength of these members is affected by residual stresses, initial bow and accidental eccentricities of load. To account for all these factors, the strength of the members subjected to axial compression is defined by buckling classes A, B, C or D given in table 7. We will see the table 7. Now, the design compressive strength PD of a member is given by P less than PD. Okay, P is nothing but the applied load. So always the applied load should be less than the design strength. Then only the safety will come. Where PD is nothing but AC into FCD. PD is nothing but AC into FCD. Now what is AC? AC is what is AE? It is AE. Okay, AE or AC also you can take, no issues. The AE or AC is equal to effective sectional area of compression member, which is defined in section 7.3.2. You can go through that. FCD is nothing but design compressive stress, which is obtained as per 7.1.2.1. Now, the 7.1.2.1 says what? The design compressive stress FCD for axially loaded compression member shall be calculated using following equation. There is an equation FCD equal to Fy divided by gamma m naught divided by phi plus phi square minus lambda square to the power 0.5. 0.5 is nothing but taking a square root, which is equal to which is nothing but psi into Fy divided by gamma m naught, which should be less than or equal to Fy divided by gamma m naught. Now what is phi? So phi is nothing but 0.5 into 1 plus alpha into lambda minus 0.2 plus lambda square. No need to worry about all this formula, which is readily available in the code book. You should know that it is there in page number 34. Now lambda is a dimensionless effective slenderness ratio, which can also be calculated equal to square root of Fy divided by FCC. What is FCC? FCC is nothing but Euler buckling stress, which is given by pi square E divided by KL by R whole square. So when I substitute it in the above formula, the formula for lambda becomes square root of Fy into KL by R whole square divided by pi square into E, where KL divided by R is nothing but effective slenderness ratio, or a ratio of effective length KL to the appropriate radius of gyration R. Alpha is nothing but some imperfection factor which are given in table number 7. Now the imperfection factor alpha is nothing but, for various buckling classes, the alpha values are given in table number 7. For example, alpha value for buckling class A is 0.21, for buckling class B is 0.34, buckling class C is 0.49 and buckling class D is nothing but 0.76. You can refer table number 7. Now psi is nothing but the stress reduction factor which are given in table number 8 for different buckling classes, or you can also calculate the value of psi for 1 divided by phi plus phi square minus lambda square to the power 0.5. Then lambda m naught is nothing but the partial safety factor for material strength. Hope it is gamma m naught. It is gamma m naught. It should be okay. Now what they have given in 7.1.2.2, the various values of the the imperfection factor alpha is given in table number 7. This is the table number 7, whatever I have told. For various buckling classes, they have given alpha values. The classification of different sections under different buckling classes A, B, C or D is given in the following table. The stress reduction factor psi and the design compressive strength FCD for different buckling classes, yield stress and effective slenderness ratio is given in table number 8 for our convenience. So psi can be taken for various values. The stress reduction factor psi and design compressive stress FCD for various buckling classes and yield stress and also effective slenderness ratio are given in table number 8. Now we have to look into the table number 8 also. So these are the imperfection factors, and the curves corresponding to different buckling classes are presented in the form of a non-dimensional form in the figure number 8. So here you can see the figure number 8. Here for various buckling classes, a non-dimensionless values are given for various values of FCD divided by Fy. Whenever we take problems, we will look into all this. Now the tables, these tables are very important. So the various values of the stress reduction factor psi for column buckling class A is given in table 8a for various values of KL divided by R and yield stress. Similarly, in the next one, table 8b, the stress reduction factor psi for various buckling class B are also given. Next one, 8c for class C, then 8d for class D. Similarly, design compressive strength values FCD for column buckling class A is given in class 9a, the 9b is for class B, 9c is for class C and 9d is for class D. We will see them when we take a problem. Okay. Now we will move ahead with the next, the design compressive stresses. These are given in table of page number 36 to 43. We have already seen that for various values of Fy and also for various values of KL by KL by R, we have the FCD values. Now the type of sections for compression members usually used are single angle strut, double angle strut, laced columns, battened columns. The compression members composed of two components which are back to back, and also there is another type of sections according to the table 13a, 13b and 14, page number 55, 56 and 57. Now we will look into 7.5, page number 47. So here single angle strut, the explanations are given. I will not go into the depth of all this. The single angle strut 7.5.1. Similarly, you can also find table number 12. Then 7.5.2, you can find double angle struts. Similarly, you can find laced columns in 7.6. So these are few of the laced columns. The detailed explanation regarding the laced columns are also given here. Then battened columns are also given in these are the battens placed. So when we take up few problems related to the battened columns, we will look into all these things in detail. Similarly, you can find compression members composed of two components which are placed back to back. You can find in class number 7.8, page number 52 also. So when we take up problems of respective categories, we will look into the code in detail. Right now this is sufficient. So these are few of the code provisions related to the compression members. Thanks for watching.